Yes, very good. Okay. Ramu is the rider and Shamu is the pillion rider. Vaidyanath says both. Yes. Who do you think will have better experience? Okay. Yes. Very good. Yes, someone says it's the rider. Yes, of course, it is the rider because he has experienced it. Okay. The pillion may be passive. The pillion rider will be passive, he will not be active. But the rider is active, he is literally driving the, riding the bike. So he's active and he will be able to come, know exactly how he drove the bike, right? How he rode the bike. So to the experience is, counts. So simulation is such because practically the students will be doing it. Okay. Whereas when we teach through blackboard or through book, the children are passive, they're just listening to us, isn't it? So the children who the person, the Ramu, who's a rider, of course will be knowing it more better. Of course, if the pillion rider is also active, then both, as you said. Okay, not right, I agree to it. So this is how exactly activity based learning impacts students. When learners actively participate, explore, question, and make decision, learning becomes meaningful and long lasting, isn't it? Right. When they are only passive listeners, understanding remains shallow. Okay. So what are we doing today? Okay, as tutors, we already know that best learning happens when curiosity is active and fear of mistakes is removed. Yes, simulation creates a safe space. Yes, that's very, very true. Just imagine you have an electric circuit in your lab. It's dangerous for children to handle it alone. There can be short circuit and a lot of other things. So simulation is a very safe space where students can explore, try, fail, and learn with confidence. And that's what makes it such a transformative teaching method. Yes, I think you cannot agree with me more. Yes, I'm looking forward for the comments in the chat box. Yes, do you agree with me? Yes. I kindly request all of you to be generous with your participation in the chat box. Yes, so that we can make this session two-way. It should not be like I'm talking, only you're listening, right? So it should be, I request you all to make it interactive. Okay. So please use the chat box actively, share your thoughts, answer questions, ask doubts, and reflect openly. For today, I invite you all to be students for a day. Okay. When I mean I invite you as students for a day, I don't mean we are here to teach you. We are here to tell you that yes, the concept can be, given in a gamification way, the simulation way, right? So that's what I mean. Be students for a day. So step into the learner's shoe, experience the process, and most importantly, enjoy the session, right? Okay, because your energy and involvement will make the workshop truly enriching for everyone. Let's learn, unlearn, and reimagine teaching together. So, over to my tutor, Sijina Priyadarshini ma'am, who will be showing you the science simulation. Yeah. Uh, Before that, all of you have registered, right? Yes, Sijina ma'am, are you ready?
Yes, ma'am.
Yeah. Um, could you tell me in the chat box 1 minute before we would proceed for the session? How many of you are attending for the first time? How many of you are attending for the first time? Because we are having this simulation training the second time, and how many of you have implemented already in your schools, and how do you find it? Do give me in the chat box also. Keep this chat box interactive. Yes, Salma says yes. How many of you have attending? Yes. Once more, please send the Google form link. Ganesh, have you sent it? Yes, we have sent you. In the last, I will be sending you the feedback form also. Please be generous to give your feedbacks also. Right. So we'll begin our simulations, and then we will be back with more interaction in the chat box. Yes, Vaidyanath says every day he's using the simulations. Yes, thank you, Vaidyanath sir. Thank you for your feedback. Yes, now we'll move on. Yes, Sujina ma'am, over to you. Thank you.
Oh, okay, ma'am. My screen is visible.
Yes, ma'am.
Yes.
Now,
Okay.
yes.
Good morning. Today I'm going to show a simulation from OLAPS on the topic cleaning of muddy water. So we all know that water is very important for our life, but the water we get is not always clean. So through this simulation, we can show students that how through a simple method we can clean muddy water. So main objectives of this simulation is to let know the process of water purification, to make students to learn the process of sedimentation, that how muddy water settle, decantation, how to pour carefully the clear upper layer, then filtration to filter the water through a cloth or filter paper, then alum using to remove suspended particles, and the importance of boiling, that how it disinfect water. So through this all procedures, we can show the simulation in a beautiful way. So let's start the simulation and see how muddy water becomes clear water. So for this, materials required: a sample of muddy water, empty container, muslin cloth or filter paper. Then we also required alum and heating device. So let's see how we will do this, the procedure of the simulation. First, we have to take this muslin cloth or filter paper. So we are taking this muslin cloth to the top of the empty beaker and place it above the beaker as a cover. Now we have to take this container which is containing the muddy water to the top of the empty beaker and pour it. Okay, after pouring, we can see that the liquid passes through the pores while the solids are trapped on the surface. So, suspended impurities of muddy water are separated by filtration. Now we have to go for the next step. Here we can see water is still muddy because of the presence of tiny particles. Here alum is there, filter paper is here. Now let's go to the next procedure. So first we have to take this alum, which is tied with a thread, and put it into the beaker. So we know that alum acts like a magnet for tiny dirt. It sticks to the fine particles and make them to sink quickly to the bottom. We have to wait for some time and let the students observe the change of transparency in water. Now we can see that even after using alum, the water have still specks of dust. See here. After this, we have to do the next procedure. Take this muslin cloth and we have to filter this water again. So after filtering, we can see it helps to remove the remaining impurities, and it is depending on the degree of contamination of the water. It takes a few hours to even a day for the particles to settle down. So this simulation shows the students how we are purifying water step by step. After this, we have to go for the next procedure, next step, which is the boiling. Now we have to boil this. So take this container and on this flame. So we know that after that boiling kills germs and microorganisms present in the water. So after that, water is boiled for 15 to 20 minutes, which kills all germs and microorganisms. Now turn off the flame and let this water to be cool. After making it cool, filter it again. So we are going to filter this water again. So see, this is our clean water, and all that here we can see nothing. So thus we obtain a clean and safer water. So finally this water is filtered once more to remove any remaining particles. So this simulation shows students that muddy water can be cleaned effectively by using simple methods. Tell them the importance of filtration, that how it that removes large impurities. Alum helps in setting fine particles, and boiling kills harmful germs. And combination of these processes make water cleaner and safer for use. This is very good simulation to tell them the importance of purification of water. We can also reset this simulation and also show them again. So this is my simulation about muddy water, how to clean muddy water. Thank you, ma'am. Soni, ma'am. Thank you.
You. Over to Barka. Next it's Barka, right?
Yes,
Yes,
ma'am.
Barka ma'am. Over to Barka ma'am. Barka ma'am, are you ready? You're not audible, Barka ma'am.
Hello,
Yeah,
ma'am.
yeah, you're audible now. Right.
So just sharing my screen. Good morning to all. Welcome to the simulation exciting session which we are having now. Here, today I'm going to use word wall to present a simple topic in English, which is WH questions. When do we use WH questions? We use WH questions when we have to find out or gather any kind of information. Don't we all agree? If you have to ask any questions, if you want to find out where this is going, who is this, if you want any kind of information, we ask, what do we ask? We ask a question. Now the most common WH words, as in why do we call it WH words? It starts with WH, like when, what, how, which. Yes. On the chat box, I would love everyone to be interactive, and if you agree with me, put a thumbs up and please answer. So this is as interactive and we can simulate how we would be doing it with the students, right? So here I have taken a word wall presentation, and we are talking about WH questions, which are really important for basic conversational skills in children. So this is a very important topic, simple one, but very important as well, because it will help them in their day to day life for a conversation purposes. Yeah. So most of the children, when they are small, they get confused between this. Now this is easy for us, but for children this becomes a little tough when they have to understand when to use what, how, which, as such, right? So we have a very simple diagrammatic representation here, which will be easy for all of us. Now let's see what it says here. Yes, ma'am. Ramu says yes, ma'am. Thank you so much, Ramu sir. Now we will see here that in this WH question, which WH question asks about the manner of process. Now, this is an exception. It doesn't start with WH. You have to tell that this is an exception. It does not start with the letter W and H, but it helps us understand the process. Which one among these which will we use? Can somebody in the chat box tell me which among these WH words we can use? It's an exception. It does not start with WH. Yes, it is how. So, what asks about the manner of process? So, how old are you? Yes, Susan. Mandrumaka, very good. Thank you so much. So how uses how are you doing? How are you going to the market tomorrow? Yes, so we use the how to understand the process. How does the bird fly? So whenever we are very curious about how something takes place, yes, about the process, the manner, the condition, how are you? Right? How are you? I'm good. So the condition of the person you're meeting, that also will you use how. And also you wanted to know the quantity of something. So when you want to know how many kilos of mango you want to buy, you ask mama, how many kilos of mango shall I buy and come? Mama says 1 kilo, 2 kilo. Yes. So how, when do we use it for process, understanding the process. We understand the condition of a person and the quantity of a person, quantity of things that you want to buy. Yes, so we have to give this little small key points for children to know. So they write how, they draw a process like this, and they also write slash quantity slash condition so that it is easy for them to recollect and revise. Yes, now we ask the children to draw a stick diagram here. Like here we have a man, so we ask a person, children, to draw some stick diagram here, and then we ask them, whenever you are going to talk about a subject as in a person, right? So what do we use, which wh word we use there? You give a very simple answer for that. Yes, here you see the head is like an O, so you just say wh. Oh, who? Yes, very simple, very diagrammatic. So when you draw head of the person, you draw a circle, right? When you draw a strict diagram. So for the child to remember easily, when you ask about a person, you draw a person and then just add a WH before it. It is who. Yes, so very simply, you can use a lot of creative diagrammatic representation. You can even annotate and show to the kids. So we drag the who. Yes, very good. Mamta, Ume, Salma, a lot of answers are coming in. I'm thankful for all the active participation. Now let's go to the next WH question. So we've learned two. We have learned how and who. Yes. So we do a little recollection every time we're showing the simulation, and we can take it up very slowly with the kids. Now we can do it in rapid form because all of us are aware about these WH questions. So I'm proceeding to the next. Ask for a reason. So when you're going to ask for a reason, why did you do that? Now, if a child is misbehaving or has broken something, what do we ask? Why did you do that? Yes, so whenever we are asking for a reason, we are going to use the thing called why, the WH word called why. Thank you, Maunika, Ramu, thank you, Ramu, thank you so much. Yes, Maitris, Samina, yes, thank you so much. Answers are right. We use why when we are using asking for a reason. Yes, so very good. You use why. Now, when you are possessing something, so here you see a person. Yes, now the child can get confused. We see a person when the person is holding something, when the person is possessing something, it belongs to them. Which one we will ask? So if I'm talking of this thing I'm going to talk about is the car. Now what I'm going to ask? Yes, Maunika, whose? Yes, whose car is this? Whose book is this? Yeah. So we use the thing whose. So again we are talking about a thing belonging to someone. Again you remember that like a person has a, when you're drawing a stick diagram you draw O, like that. You, when it belongs to someone, whose. Similarly you can use it. Very simple. We can explain to the kid, when you're talking about somebody possessing something or having, it belongs to them, you use whose. Next, ask to specify which or more. So when you have to choose, when you have to choose between two things or three things or many things, you use which. Very good. So you're all answering well. Asked to specify which one or more of things or a set they want to choose. Like you're choosing between colors, which of the following answers would you choose, right? So which is a proper thing. Now even here I can, which, I'm asking you which WH word will come over here. So I'm asking you to choose. Whenever I'm asking you to choose or asking you an option, then you use the WH word which. Now when we are talking about time, right? Whenever you're talking about time, you use the WH word when. Yes, use the WH word. So ask the children to draw a clock, and then write when next to it. Yes, and for which you can ask them to write option A, option B, and in the center you can write which, so they can note these things in a diagrammatic representation. Yes, ask about a place. So yes, Maunika, Rupavati, thank you so much. The answers are very correct. So whenever you're asking about a place, where are you going, where are you going, so you ask them to draw a house or a school and draw a location mark on it and write where, so it is easy for them to recollect in a pictorial format. Yes, next, ask about a thing or an action or an idea. When you're going to ask about something, what is this, when you don't know, yes, so you will use the very good Maitri, Physias, Rupavati, yes, we use what. Now the children can do this on their own, they can do mistakes, they can do it all right, and when they submit the answers, when they click the submit answers, see what happens. Yes, you get whether which one are right, which one are wrong, it will be shown. Yes, and once you've done that, you can also, if somebody has done a mistake, so example, we have leaderboard where scores will be shown, we have show answers and start again. So if you want to redo it with another child, you can start again, but if you want to discuss the answers at the end of the session, so you can recollect it with them, this is how it will be shown. If they have done any mistake, you will get a cross mark and the right answer would be mentioned here. I'll show you in some of the thing. I'll purposefully click a wrong answer so we can see how it is reflected in the word wall activity. Yes, so now we have the show answers. Now I'm going to do a small quiz with the same topic, WH questions. Yeah, so let me stop sharing and reshare the screen again. So here I'm going to reshare the screen with you all and we're going to have a small quiz. In this I will try my best to remember to choose the wrong answer, so we can see which one would be the right answer. Yes, the chat box, 1 minute. Yes, I can see the chat. Yes, good learning activity in English subject. Thank you, Maunika, ma'am. Thank you so much. Now, Dash is your best friend. So here we are talking about a best friend. Best friend is a person, of course. Yes. So Dash is your best friend. You have to remember who it is. We draw a stick diagram. We draw. Very good. We are clicking who. Lot of answers are coming in. Nachiketa, Susan, Juluru, Farhana. Very good. Now next, Dash do you want for your birthday? Now for the birthday, what do we get? We get a gift. Gift is a thing. So what do we use? We use the WH word what. Yes. So we click on what. Very good. All of you have been replying very well, very quickly. Next, Dash is knocking at the door. When someone is knocking at the door, it's going to be a person. So again, when you tell the child, you say it's a person. So use the WH word for a person is who is knocking at the door. Yes, who is knocking at the door? Very well. Dash do you go on Sundays? Now, this is a little tricky and confusing. You will get confused between, a lot of you are answering rightly. Where do you go on Sundays is the correct answer. But you can also put if there was a to, right? How do, dash do you go to the market on Sundays? If there was a to the market, the question will be how do you go to the market on Sundays? Yes. So, or why do you go on Sundays? If you why do you go to the market on Sundays also will be correct. But here there is no to, the place is not mentioned. Dash do you go on Sundays? So you will use the WH word where. Yeah, where do you go on Sundays? Okay. Next. Next one is dash color do you like more, red or blue? Which? Yes, we are giving option. Now next is this is how you can ask quiz. Like I have created about 10 quizzes here. So here you can write the book, dash book is on the table, whose book is on the table, but I'm just making a mistake here on purpose. What? It is immediately reflected and immediately the right answer is shown here. This is how I wanted to show. See, when a child does a mistake, the mistakes are immediately rectified. Here there's a cross mark and over here we have the correct answer is reflected here. Yes, dash book is this on the table. This is whose book is the right answer, but I have chosen to show the wrong answer, how it will be reflected for the children over here. So this is a great way for self-learning also for the kids. They can take up any number of quizzes and learn about a topic. Now, we have understood about WH words. This is a quiz format. Now, I'm going to go on a new topic called homophones and homonyms, right? So, I will share my screen again. Just a moment. We'll look into another topic as well. I hope this topic was enriching and interesting for all of you. I'm going to go with the next topic of the day, which is homophones and homonyms. Yes. Now we handle for Uttar Pradesh. So there is also some words written in Hindi. We'll just skip through that. That's not a issue here. So I'm just telling you can even include your regional language in the homophone preparation. So homophones and homonyms, let's understand what is it. We all are already aware of it. We're just going to do a quick recap. But for the children, they'll be learning it for the first time. So you can just read a passage to them. So read a passage and ask them these words sound similar. Yes, like to and T with a double O or T, W, O. So you can just make a paragraph with it and help them understand the concept of homophones. So with the word itself, homo means same or similar. Phones means it phone. Just give them like an action called phone, and they say in the phone they're hearing the same sound. So phone, you use your ear. So what you're hearing is very similar. The sounds are same. So homophones are words that sound similar but have different meanings. So you just use the keyword called phone. Ask them, they'll get confused. Homonyms and homophones and homograph. There are different types. So what is homophones? How does a child remember? Just tell them, how do you listen to the phone? You use your ear. So you use your ear. When you're hearing the same sound, similar sound, but the meaning is different. Yes, so this is very simple, similar way of telling. So for example, road and road. Here road is the road they are riding the bicycle on. Road is how they are riding. He rode the bicycle. Yes, so they are sounding similar. The spellings are different. The meanings are different. Yes, so this is what is homophones. So here you can display with a regional language as well here. So we're not going to go into this. I'm just showing that you can do. This is called flip the tile type of method where we have used this presentation, that this different formats in which you can create the world word activity which is available. You can choose the format which you want. Now homonyms are words that have spelling and have different meanings. So they have the same spelling. So if you say the spelling is BANK, bank, but they have different meanings. Yeah. So these are homonyms. Yes. Next we will explain this concept bank as in the money bank and then the river bank. So there are different banks as such. Now homograph I have not mentioned here, kids. So homograph is something which I have not mentioned in this activity, but over here homograph, if you may ask me what is it, can somebody tell me in the chat box what a homograph is? Can somebody tell me in the chat box what is a homograph? So yeah, we'll explain it. Homograph will have the same spelling. Okay, so we saw what is a homophone. We saw a homonym. Now we will see what is a homograph. Now homograph will have, you can also use an option where you're going to type in the thing. Yes, Monica saying same meaning with different spelling. Okay, same spelling but different sound. So homograph, you will, yes, very good. You will have the same spelling. In homograph, you will have the same spelling and different sound. Can I, very easy, very thing. One red, red. Yes. So here, read. I am read this book. Read this book is when you're talking in the present tense. I read this book. So the spelling is READ in both. Yes, same spelling, different sound. Yes, same spelling, different sound is what a homograph is. When you use read, when you say read, it's like you read the book. You're talking about the present tense. Yes, now here it will be, how will you understand the difference when the sentence comes? Read this book now. Yes. So when you're telling, you will pronounce it as read. You will not say as read. I have already read this book. Now you're talking about the past tense. Of course, the action is the same here. Read, it's you're reading a book. So here, read and read are two different things. Example, you can even say, you lead the way, then led is there. Yes. So lead, led. Yes. So these are, they found lead in the noodles. They found lead in the noodles. Yes. And lead is when you say, please lead the way. Take it forward, you take us to through the thing. This is what homograph is. So we saw homophone, homonym and homograph. You can individually introduce these concepts or you can introduce it together. Yes. Now we've understood this. We can annotate like this and show. You can type in the words also and show in. Yes. So now next we are going to go and proceed to the next thing. So here we are going to introduce some homophones alone. We're going to tell about the three different types of homophones, homonyms and homograph, but we are going to specifically talk about homophones. Now sun, S-U-N, the sun is rising in the east. So you can draw a sun like this, and for S-O-N, sun, you can just draw a person, right? You can make this a head, so you can just tell them in an easy way. This is sun, where you're going to draw a person. My son's name is Bharat. Yes, so this sun and sun can be a homophone. Spellings are different, sounds are similar, and meanings are different here. New. I bought a new dress. I bought a new dress. Knew. New. I knew the answer but could not muster the courage. Some people know the answer but they are not able to come forward and answer because they are having a little low confidence or they're not able to muster the courage as such. So this is how you can even show it as a paragraph over here and present it. Yes, so this is how you can show different times. So we have a lot of different times, hair and hair. You can talk, you can put a picture, also introduce a picture in this, and also you can talk with the sentences over here. Yes, hair and hair. So now we will go to the quiz related to this. See and see. Yes. So see, you can make the double E as two I's and tell the children that this is a simple way. So you can convert the SEE, C, which is for eyes, vision. You can just convert it into eyes. See, it's a sleepy eyes of a person. So they are seeing with the eyes. Yes. So this way also you can make it a very interactive session for all the kids to understand the see. To see is to use your eyes. Yes. Now SEA is for the sea. You are talking about the blue sea. So this is one of the activities which you can show when you have a lot of things to discuss about. You can use this activity. Now you can even, yes, Susan, Mandrumaka, when you're having a paragraph kind of content to discuss with your children, you can use this kind of activity where the words are very legible. Yes. So again, if you show answers to discuss, it will be showing like this. Yes, you can even write the question here and the answer here. That way also the presentation can be. Now I will stop sharing and reshare the screen and we'll go to the next activity again. Just give me a moment. So on homophones versus homonyms also I've created one activity. We'll just do two examples and then move to one more activity. Yes, because all of our tutors are willing to share the information with you all. This is going to be an exciting Saturday for all of us. So it's very good to learn and discuss on how to make sure the children are learning very well. So we're going to do only two each for homophones and homonyms and move forward. Now, homophones, what do you say? Remember the phone in your hand, you're listening. So, what words are you're listening to the same? Like break, break. Yes, break is as in the car's brake, and break as in you broke the glass. So, that is again a homophone. Can all of you be active on the chat box like the previous session? Can you tell me band and band? Yeah, what would be? The spelling is the same. Yes, it will be a homonym. Now here you see seal and seal. Yes, The meanings are different. Very good. Which category will come in? If it's homophone, put P, and if it's homonym, put N in the chat box. Okay, now you tell me C/C. It's a P or N? Okay, band is an N. Yes. Now, Monica, can you tell me? Susan, can you tell me seal/seal? Seal as in the seal of a particular logo or an envelope, and seal as in the animal. Yes. So yes, it has the same spelling. Yes. C/slee is a homophone. Very good. All of you have answering very correctly. Okay. So well and well, it's the same pronunciation, different meaning as such. Yes. So now we've understood what a homophone is and homonym is. Yes. So we'll move on to the quiz related to homophones. So like this, you can categorize with the children. This you can do it for categorization purposes. Now I'm not completing this activity because we are short on time. A lot of tutors are waiting to present. We will go to our next activity, which again is in a format of quiz. Yes. Now I will share another screen with you. Yes. We'll just do two and then we will move forward. My Zoom is not there.
Barka ma'am, your screen is not visible. No issues. We'll have Pallavi.
There's
Pallavi
been
ma'am.
an issue. There's been an issue. I will hand over to Pallavi ma'am.
Yeah, thank you, Barka ma'am. Over to Pallavi. Pallavi ma'am, admin, please send the registration link. Only 11 of you have registered, others haven't registered, so kindly register. We'll be sending you the link now. Yeah, over to Pallavi ma'am.
Yes, thank you, ma'am. Good morning to everyone. Welcoming you all to this one stage simulation training program. Quickly, we will move towards the simulation. I'm sharing my screen now. I hope everyone can see my screen. Yes. So you might look at the screen and come to know that today I'll be presenting the simulation regarding the mathematics session. So we have the topic called as integers. So here on the screen, you can see the square blocks wherein we can show them how the numbers or number system has been classified. Quickly, I will show here. 1 minute. Yes. So here we can tell them the first part is natural numbers where the numbers begin from 1, 2, 3, 4, 5. Then we have whole numbers which includes 0. Then we have integers, wherein we have positive numbers, negative numbers along with 0. If we want, or if we are teaching regarding national numbers and irrational numbers, even that group can also be shown. So here we tell the students how the numbers are classified in the number system, along with the meaning of integers and how integers include which all numbers are included in integers. Coming to the next part, here the most important term in integers is number line because we represent integers on the number line. So here we come to know the meaning of number line. How does the number line looks? What all it contains? 0 is also known as origin. Then to the right side of 0 we have positive numbers. To the left side of the 0 we have negative numbers. Using the number line, we move forward, that is, addition and subtraction of integers. Here we have addition of integers, wherein you can show the first sum -5 plus into the bracket 3. So -5 is a negative number, whereas 3, which does not include any sign, it means it is a positive number. So when we add them, we get -2. So on the number line, we can explain this calculation. So first we have minus sign -5, which comes to the left side of the 0, that is here. So you can see the red mark which has been pointed out. Then we have 3, which is nothing but plus 3. It means we are moving again towards the right side. So if when we move towards the right 3 places, we get here minus 2. So our answer is minus 2. Like this, you can also change the numbers here. Yes, whichever numbers you want. We have here negative numbers and here we have positive numbers. So along with that, when you make changes, here the calculation on the number line or the representation on the number line also varies. Along with this, you can also ask the students questions based on our calculations. Yes, and you can type your answers here. Now, we have also the calculation part here, wherein you can conduct a quiz thing for students. So we have additions of integer. So minus 8 plus, again we have minus 11. So what answer do we get here? Can anybody tell me? Can we have the answers in the chat box? Yes. So we have minus 19. Yes. So minus 19. So shall I put the answer minus 19? So I just put it and then I just click enter. So you can see the green mark here. Yes. So this is the right answer. Like this, if you want any kind of help, then you can put here. So if you are correct, you are going to get a green dot. Otherwise, it will remain red. You have to put your answers and press enter. All right. So quickly, we'll move to the subtraction of integers. So here we have subtraction of integers. This simulation includes both addition as well as subtraction. If we move this pointer towards subtraction, then you have subtraction. So you can see the sign in the middle gets changed. If you want addition, you can do the addition. So in case here, I'll put it on the minus. So you can change the numbers according to your calculations here. So I've taken plus 3 minus into the bracket minus 4. So the answer comes as 3 as it is plus in minus into minus becomes plus 4. So 3 plus 4, 7. So on the number line, so plus 3, it is here. Again, when it is minus into the bracket minus 4, which according to the integer rules, it becomes plus 4. That's why we move forward towards the right, which gives you 7 as the answer. Like this, you can show the students regarding how the same numbers will have different answers when you do addition and subtraction. Now, for the same numbers, if I do the addition, we get minus 1, and how the representation also changes here. Yes. So, one of the real life application of the integers can be seen in temperatures or describing the weather climate. So here we have the practical implication task wherein you can see the temperature or the thermometer wherein both the side the numbers the integers are mentioned, and based on it we have the questions here. The temperature is minus 10 degrees Celsius. How much must it fall to reach minus 18 degrees Celsius? Use the thermometer on the left for help. So, can anybody tell me what will be the answer when the temperature is actually at minus 10 degrees Celsius? So, how much it should fall to reach minus 18? So, if we see here minus 10 degrees Celsius, it is at 10 degrees Celsius. So, I'll just pull the blue mark to minus 10. Now, we have to go to minus 18. So, minus 18 means this is 15, 16, 17, and 18. So, here it will come. Yes. So, how much does it fall? Can anybody tell the answers? Yes. So if you want, you can even ask the help here. So here we get the calculation, that is minus 10 minus into the bracket minus 18. So the answer that we can get is minus 10 minus into minus becomes plus. So our answer will be minus 2. So shall I put it? Sorry, not minus 2, sorry. 8. Shall I put it? Let's see. Yes, excellent. Your answer is correct. So for a moment, I'll just enter a wrong answer and show you how does it work. This isn't correct. Illustrate the problem on the thermometer. So like this, we can show the students how integers are used in real life applications. I thank everyone who have given me the answers and their responses in the chat box. Thank you so much. I request the next tutor to please start the session. Thank you everyone. Thank you so much.
Thank you, Pallavi ma'am. That was awesome. Thank you. So here I'm
Thank
back
you so
with
much, ma'am.
English simulation, English word wall activity. Today we are going to do preposition of time and exclusively at, on, and in. Lot of confusion, isn't it? Yes. So today you are students. So be students and actively participate. Right. Yes. So I'll share my screen. So we'll have a small story. Okay, in the story, just identify the prepositions, or you are students, right? So you don't know what is a preposition of time, maybe, right? Like that, we will go proceed. Okay, so yeah, we'll be exactly students today. Ria woke up early in the morning. Yes, Ria woke up. Who's the main character? Ria. Okay, Ria woke up early in the morning. Okay, what happened? She decided to meet Sita on Saturday. So, in the morning, on Saturday. Okay, just note the point. In the morning, on Saturday. Right. So, let's see what happens again. They agreed to meet at 4 p.m. So she decided to meet on Saturday at 4 p.m. So when we are talking morning, we used in. When we talk about the day, we used on. And we spoke about the time. When we are specific, we spoke about, we said at, right? So let's see what else it has, right? So, okay. On Saturday, Ria and Sita met at 4 p.m. So finally, both of them met at 4 p.m. Right. Okay. So what else they have to do? Sita mentioned reading a book on Friday night. So Sita mentioned that she read a book when? On Friday night. So on Saturday, on Friday. Can you notice the pattern, children? Yes. Okay. Then Ria said that she has to visit her grandparents at night. So Ria said she has to visit her grandparents at night. Okay, when? At night. Okay. Then we have at 6 p.m. they waved goodbye to one another. So again, at 4 p.m., at 6 p.m. Okay. And at 8 p.m. at night, she has to meet her grandparents. Ria started her journey to her grandparents' house. She reached late in the evening, to be precise, at 8 p.m. So what are the timings we saw in the story? Okay, 6 p.m., 4 p.m., and 8 p.m., right? Yes. So 4 p.m. is when they were decided to meet at 4 p.m. They waved goodbye at 6 p.m. Ria went to her grandparents' house at 8 p.m. So whenever you saw the time, children, you saw it's at. And whenever you saw Saturday, Friday, you saw it's on. So let's now see what are these in, on, and at, right? So how did you like the story? Yes, please let me know in the chat box. How did you like the story? Yes. So now what we will do is we will tell them we'll get them to the actual, what is this story about? Yes. Now we are going to get you into the grammar part, right? So here we can tell them what's the definition, and then we can tell them what are the types of preposition, location, direction, time. I will not, do the activity because I'll just run through so that you can have an idea. Then we can tell them in means what? In means it is a, how is it? Is it more specific, what is at? Everything we can tell them. So at is more specific, and in is least specific, and on is more specific. Yeah, like degrees of comparison, we can teach that also. And with this circle, we can make it more easy for them. See how the time, when it's at, it's a smaller time, and on, it's little bit bigger than the at. And when it's bigger period of time, like years, decades, and months, all these we will use in. So we have given over here a diagrammatic representation so the students will understand more easily. See this? At means time, night, noon, sunrise, dinner time. Okay, why lunchtime is at? It's not telling me the time because it is specific. In your school, it can be at 1 o'clock. In my office, it can be at 2 o'clock. So, but the lunchtime is specific, isn't it? Sunset, every place, different timings, but it is again specific. So that all you can explain them over here. They will get all these major doubts. Then on is any events on all the Sundays, Mondays, all the days, date and events and dates. That is, remember 24 hours, you use on. When it's more than 24 hours, like that, you use in. Okay, like January, in the 2019, all this you use in, right? So then we can even denote them with the triangle, which we usually do it. At small, on little bigger, and then in wider, the more bigger time. Yes. So we have activities that we can ask questions and do that also. But since we will not have much time here, we'll give them in more input, like at means 5 p.m., 12 o'clock, 7 a.m. When you talk about hours, when you talk about days, Friday, my birthday, all this. And in, we have over here weeks, months, years, decades, centuries, 2 weeks, July, May, all the months and years. So exception is 5 minutes, in the morning, in the afternoon. For period of days, in the morning, in the night, in the afternoon. But night, we can use both. In the night, at the night. So why? That also we can explain them. Here, at night or in the night, which one is right? So we can give them the script of that also. So this is all about from the story, how you direct, we can direct them to the through the grammar definitions. Slowly bring them to our way. Yes? How do you like it? Yes. So I can see some comments in the chat box. Yes. How did you like it? It's telling about preposition. Very good, says Susan. Yes, thank you. Thank you so much. Yeah. So then now we will take them to the, again, after explaining, we will take them. Now it's your turn to be actively participating. Now let me, will you drop each thing? Now Thursday, will you drop it in, on or at? Come on, tell me. In, on or at Thursday. Yes, I'm getting the answers in the chat box. Yes. Very good. Very good. Thank you, Shamina. And Farana, everyone says on. Yes. Why do you do it on at, why are you doing it over there on? Why? Because we know it is what? Right. We know it is, 1 minute. It is a day. Okay. Now, 5:45, it is specific. Okay. So at 6 a.m. again, it is specific. Yes, very good. I can see a lot of you interacting in the chat box. Yeah, tell me now. New Year's Eve or day. Where will you drop that one as? Okay. Padma, Umain, Salma, and Sugu, everyone are answering very good. So it is a New Year's Eve or day will come on, because I mentioned when it is day and events, you will say on the New Year Eve. Okay, not at, right? Yes, not in. You will, in events and days, you will drop it in on, right? Very good. Good answers. Wednesday, it's on. Now I'll randomly pick up somewhere and ask you 2025. Tell me 2025, where will you drop? In, on, yeah, at? Yes? Very good. I got the answers in because it's a long period of time. So you have to make the students imagine 2025, 365 days. So it's a long period of time. Directly put it in. Now let's go to sunset. Sunset, where in on your at? Come on. Sunset? Yes, it is specific at every place, different timings, but again, it's specific. Yes, at sunset. Then, come on, let's do this. 23rd of Friday. 23rd of Friday? 23rd is there, Friday is there. But whatever is there, date is there and day is there, but still 24 hours. So we will go to on. Yes. Okay, so this is how you do this activity. Post that you can even have them a small quiz. Yes. I get up, dash 7 o'clock. Time has come, become alert, specific. What will you write? Yes, A option is right. Very good. Thank you for the active participation. I can see 100 answers pouring in. Very good. So it is at 7 o'clock. Right. Very good. So my birthday is dash. May. What is it? May is a month. Month, 30 days is there. 24 hours are not there. 30 days long. It's long period. Right? So what will you write? My birthday is? What will you write? So this is how it goes about. I will not take much time. So this same activity, you can see here. You can even change the template. Now, I don't want to play it in this quiz format. Just imagine. I want to play in this format. Okay. So I want to play it in this format. So it's in 1, 2, 3, 4, 5. Now I create a curiosity. Come on. Raju, come and open box 3 and find your question. The child will come and open the box 3. Now you tell me as students, which number do you want to open first? Come on. Yes, which number do you want? 7, Susan says. Okay, Susan, you have it. 7, what's your question? Come on. Susan, please answer. I was born dash. Come on, Susan, it's time. Yes, Susan says. I'm just losing track of the chat because so many answers pouring in. I was born dash 2008. So we will write period, long period of time. Time is up. See, you can keep the timer. Right, Susan. Perfect answer, Susan. So this is how you create a curiosity in the students and you can literally play. Now, Vaidyanatھ says 1. And who else have given me numbers? Ume Salman has said 8. So yes, you have it. Sorry, others I have missed out. I'm sorry, because I'm losing track of the chat. Yes, I get up dash 7 o'clock. Yes, that's question 2. Right, perfect. It's specific, so at. Perfect, well answered. Good job. So when the other students also see the curiosity, what's going to come, which question, they will never forget for life. Don't you agree with me? Yes? Yes. Okay. Do you want to do all questions, my students, today? Or shall we go to the next? 5. Lot of you have asked 5. Chalo, we'll see 5, one question, and then we will wind up for now when I pass it on to the other tutor. So let me know how was the 5 is your question. Would you like to go to the cinema dash night? Oh, that's an interesting one. Yes. At night. Very good. Very good. So, would you like to go to the cinema? Yes, children? Yes, everyone answered very well at. So, how did you like the session? How did you enjoy as students? Please give me your feedback, students. Right. Thank you so much for the active participation. Thanks a lot. It means a lot. You all have participated so well. I can see answers still pouring in. You're so interesting, Monica says. Thank you, says everyone. Okay, number 10 was time up. So we will last. Okay, children, you are asking me for 10. I answered you. Okay, now this is last question. Okay, it's the question over here. I have dash. Dash Mondays, I have 5 lessons. Day has come, okay, on Mondays. All right, thank you. I'll pass on to the next tutor. Vidya ma'am, over to you. Thank you so much. I hope you all have filled the participant form. Soon I will be sending you the feedback form. Please do fill up the feedback form also. Yes, Vidya ma'am, over to you.
Good morning to all. Today in Maths, I'm going to explain the concept of probability is a mathematical way of measuring the chance or likelihood of a particular event happening. In that probability, I'm going to explain the concept of sample space with this the help of the simulation. Okay. So what is mean by sample space? We already know, right? The sample space is the set of all possible outcomes of a random experiments. It is usually denoted by the letter ES, correct? So, in this activity, I'm using three coins, okay, for getting the sample space of tossing the coin. So when I'm tossing one single coin, a coin is a flat piece of metal, usually round, that is used by a government and used by the money. So in parts of coin, what are the possibilities are there? One head and one tail for a single coin. So now I am tossing. So this is the head or tail. Head, correct. Again, I am tossing the coin. So I am getting tail. Okay. For tossing one coin, I am getting one head and one tail, right? Yes, the set of all possible outcomes of a random sample space associated with the experiment. If a coin tossed once, the sample space we will get one head and one tail. So the number of elements is 2, correct? So that 2 to the power 1, that is denoted as 1, okay? And now I am going to toss two coins, two times. First coin and second coin. So simultaneously, I am tossing two coins. So first coin, it is a head, and second coin, it is the tail. Again, for 2 points, both are tail. Both are head. So these are all the possible outcomes. So if while you are tossing 2 coins, the possible outcomes are head and one tail, two head, and one tail and one head. Correct. So the sample space is 4. Number of elements is 4. So 2 to the power 2 is 4. Correct. 2 denotes the number of coin tossed. Next, I am going to toss 3 coins. Okay. Tossing simultaneously. So now I am getting 2 heads and one tail. Again, one more time. So 2 to the power 3, we have 8 possible outcomes. Correct. So 4 times over, now 5th time. This is the real time example. You can show it to the students in class. So 3 head to 3 heads. So now the sample space is consecutive 3 heads and consecutive 3 tails, and 2 heads, one tail, one head, tail, one head. Likewise, we got 8 sample space, right? So 2 cube is 3 denotes the number of coin tossed. 2 is the base, 3 is the number of coin tossed. So now we will find the sample space when a coin is tossed 4 times. Okay. So it is just I am tossing one time, 3 head and one tail. If I am tossing again, So the elements 16. 2 to the power 4 is 16. 4 is denotes the number of coin tossed. 2 is the base. Correct. So sample space of coin, while toss one coin, the sample space is 1 or 2. 2. While toss a coin is tossed 2 times, the sample space is 4. Coin is tossed 3 times, the sample space is 8. Coin is tossed 4 times, the sample space is 16. Very good. So the conclusion, if we toss n times, the possible outcomes is 2 to the power n. So this is the possible outcomes of the coins tossed 4 times. Now I am showing just 4 times. Tossed n times, the possible outcome is 2 to the power n. Correct? Yes. Now I am showing one question answer part. Okay. When a coin is tossed once, how many possible outcomes are there for the sample space? 2. Yes, 2 to the power 1 is 2. A fair coin tossed 8 times, how many elements are there in the sample space? A fair coin tossed 8 times, how many elements are there in the sample space? 2 to the power 256. Okay. In the sample space, in the sample space, the 4 coin tosses, how many out 2 head? How many outcomes? Exactly 2 head. 3. How many elements are there in the sample space when we toss 5 coins? 2 to the power 4 is 16. Then 2 to the power 5 is 32. Yes. When a coin tossed 3 times, how many possible outcomes are there for the sample space? Possible outcomes of sample spaces? 2 to the power 3, 8. If a coin tossed repeatedly, does the sample space have a finite number of elements? No, it's infinite. If you toss the coin repeatedly, the sample space have infinite number. If 2 coins are tossed once simultaneously, or if one coin is tossed twice, would the outcome be the same in the sample space? 2 coins tossed once simultaneously, or one coin is tossed twice. The outcome of sample space is same or not? Yes, both are same. Correct. When a coin is tossed 4 times, how many possible outcomes are there for the sample space? 4 times, 2 to the power 4. 16. Yes, exactly. In a sample space of 4 coin tosses, how many outcomes have at least one tail? At least one tail. 15. So 2 to the power 4 is 16. 16 minus 1, 15. When a coin tossed twice, how many possible outcomes are there for the sample space? 2 to the power 2 is 4. So now I am submitting my answers. We will check if it is correct or not. So answers are correct. Likewise, we can show we have a n number of simulations for in mathematical in live streaming. Okay. This activity also we have the dice simulation also is there. So I think it is very interesting for you. Thank you for giving this opportunity. I am overing to Sandanam sir.
Thank you, ma'am. Good morning, everyone. I am a physics tutor. Today, we are going to explore one of the most fundamental concepts in physics, that is projectile motion. Whether it is a basketball heading for a hoop or a launched satellite, the physics remains the same. To help us visualize this, we are using the FET projectile motion simulation. This tool allows us to control gravity, air resistance, and launch angles to see how they affect a moving object. Okay, as you can see, we have 4 modules: intro, vectors, drag, and lab. We will go through each one to build a complete understanding of how things fly through the air. First of all, intro screen. Okay, this, click on the intro title, move the canon up and down like that, and you can change the angle like that. Yes, okay. So this is a basics in the intro screen. Here we have a canon. You can adjust the height. You can click and drag the base of the canon to change its height from the ground level up to 15 meters like that. And you can change the angle. Okay. And initial speed. At the bottom, we have a slider for initial speed. Let's start with the 15 meters per second. Okay. First of all, here you can select pumpkin from the drop down menu. Okay. Press the red fire button here. Notice the path it follows. This curved path is called parabola. This curved path is called a parabola. Now look at the top right. We have a wonderful important tool. So this is the tool to measure the some important times, that is time, range, and height. So here, first of all, time. If I place this tool on any point of the path, it gives us 3 critical pieces of the data. For example, here, time, how long the object that has been in the air. Okay, and range, the horizontal distance of the cannon, and height, the vertical distance from the ground. You can change into the another point like that. So this is much faster than doing the kinematic equation by hand. Now, mass and material. So you can change the object from pumpkin to, for example, baseball, football. Okay, right. Or you can select even into human. Fire each one. Okay, and baseball. Yes, same. A common question in physics is, does a heavier object fall faster? So in this intro mode, air resistance is turned off by default. Watch what happens when I fire a pumpkin, a baseball, like human, like that. Then heavy baseball, cannonball, and even a human. Notice that they all follow the exact same path. Yeah, already you saw that. So this confirms Galileo principles. In a vacuum, the mass of an object does not affect its trajectory. Gravity accelerates everything at the same rate. Gravity accelerates everything at the same rate. As you know that 9.81 meters per second square. Yeah, regardless of how heavy it is. Okay, right. Now go into that vectors. Okay. So vectors. Let's look at the why begin the curve. In the vector screen, we can see the forces at work. I will enable the velocity vectors here. Okay, and also components here, like, okay, right. Now fire the ball. Yes. So again, here you can see the two green color line. Yeah. Look at the green arrows. The horizontal arrow, we can call this V of x, stays exactly same length horizontal arrow throughout the flight. Why? Because there is no horizontal force pushing or pulling it. However, look at the vertical arrow. We can call it as V of y. It starts long, gets shorter as it reaches the peak, and becomes 0 for a split second at the top, and then grows longer as it falls. This is because gravity is constantly pulling it downward. This combination of constant horizontal motion and changing vertical motion is what creates a parabolic shape. Okay. But in real world, we are not in a vacuum. We have a air. So let's move into the lab screen. Here, lab screen. Okay. Here we can turn on the air resistance. Here we can turn on the air resistance. Okay. So first of all, just to fire the one ball or golf ball. So meter distance approximately 29.1 meter. Okay. Now turn on the air resistance. Again fire the same ball. Yes. Yeah. So watch the trajectory now. It is no longer a perfect parabola. The object falls shorter because the air is pushing against it. Okay. So this is where mass and diameter finally matter. Okay. Clear? Okay. Now increases the diameter slider 0.30 meter. Fire the ball. Yes. Increases the diameter again. Fire the same ball. Yes. Okay. So a larger diameter creates more drag, slowing the object down faster. Conversely, a heavier masses. So here you can see the mass slider. Again I will fire the golf ball here. Okay. Now we can change only the mass. Again. Again. Yes. So a heavier mass has more inertia, allowing it to cut through the air more effectively than a lighter object of the same size. Okay. You can also play with the altitude. Yes. Little bit change. Yeah. So you can also play with the altitude. Higher altitudes have thinner air, which means less drag and longer distances. Okay. Right. So in the FET projectile motion simulation, it is a powerful tool which is used to turn abstract math into something you can see and feel. We have learned that velocity is split into horizontal and vertical components, and mass only matters when air resistance is involved, and angle. Again, I will show one thing. Angle. Suppose So you can choose like 60-degree angle. Yes, fire the ball. Again, you can change into angle 30-degree. Yes, fire the ball again. Yes. Now change the angle into 45-degree. Yes. Yes. Yeah. So here's a classical physics, the challenge. Which angle gives a maximum range? Okay. At 30 degrees, the object hits a ground quickly. Yeah. At 60-degree, it goes very high but does not travel far. At 45 degrees, we find the sweet spot. This angle typically provides the maximum horizontal distance. So also notice that 30 degrees and 60 degrees land in almost the same spot. Yeah, these are complementary angles, and in a vacuum they always result in the same range. So 45-degree is the maximum range, maximum angle to best bet for a distance. Okay, so that's all for today. Thank you everyone. Thank you teachers. Now over to next tutor.
Thank you, Sanjana Palnisa.
Thank
Dear
you.
tutors, I have sent you all the feedback form in the chat box. Please do take time and give your feedbacks. And the teachers who haven't registered, I have sent you the form in the chat box to register also as a participant. Please do register as a participant too. Thank you so much. Over to Ashwita, ma'am.
Thank you, Soni ma'am. Hello all to the respective teachers and the coordinators present here. In today's session, we shall learn about the science in a very fun-filled way in connectivity to our daily life. Yes? Shall we learn it? Great. So now, let's revisit our childhood fun-filled magical games that we used to play. Haven't you all played this game where you rub this plastic comb or a scale over your hair, rough, dry hair, and then when you bring it towards the cut paper pieces, they attract. Or while you walk on a socks or on a carpet, and suddenly when you touch a metal knob, you get a shock, a sharp shock, isn't it? So when you vigorously rub a plastic ruler or a scale or a comb on dry hair or a wool or a woolen sweater, this charge that plastic material. When you bring the tiny lightweight pieces of paper or tissues, the paper pieces will start jumping and it starts sticking to the plastic. Okay, sometimes dancing or falling. And it was such a fun-filled game when we were a child, isn't it? And now, as a grown up, as an adult, as a teachers, we know that plastic is an insulator, allowing the charge to build up on the surface. And a balloon, when it is rubbed against a hair or a plastic plane, it also works, often producing a stronger effect. And we call it as static electricity, isn't it? Now, let us start understanding this in a more wider sense, or the students can have a deeper perception on it through a simulation. I shall share my screen for a simulation that makes us easily understand about the static electricity. Hope you all can see my screen. Yes? Can we have some comments? Chat? That's great. Thank you for all your responses. So now here, you can see a woolen sweater, a balloon, and a wall. Okay, through this, let us make the student understand about the static electricity and law of conservation of charge. To begin with, static electricity is a fascinating phenomenon that occurs when there is an imbalance of electric charge within or on the surface of a material. And this great balloon and static electricity simulation is one of the best way to visualize these invisible charges. So now let us get into it. See, there's a balloon here. When I rub the balloon over this woolen sweater, purposefully have put all the charges to be seen. You can also select show no charges, But instead, if I would select this option, show all the charges, the students can have better idea of this plus and minus mark. Apparently, protons and the electrons. When I rub this, you can see all the negative charge is being attracted to this balloon. And now, what is happening? It is getting attracted. Isn't it the same thing that we did? Combing the hair over a plastic comb, and that would attract the small pieces of paper. Yes, the same thing is happening here. So again, another magic. Here at least, the electrons had got transferred, but here it is moving and the balloon got stuck to the wall. I can try doing this experiment, 2 balloons as well. And here, this is not getting attracted, but when there is shift of electrons, this get attracted to the wall. Isn't it fascinating? Yes? Okay. So now, through this simulation, what are we taking back? What are we understanding? That when object initially has an equal number of positive, plus, and negative charges, in nature, most of the things are electrically neutral, right? So that is where you don't have any attraction. But these are stuck in the nucleus of atoms. In the simulation, you'll notice the protons as well as electrons. When the balloon pulls the negative electrons of the wool, ideally, I'll show it again. This way. So when it pulls the negative electrons of the wool, the balloon now has a net negative charge or more minus sign than plus sign. The sweater is left with a net positive charge because it lost its electrons as the balloon is taken away. So this shows the law of conservation of charge. The law of conservation of charge states that the total electric charge in an isolated system remains constant. But charge cannot be created or destroyed. Only it can be transferred between the object or rearranged. Similarly, here the electric charges, the negative charges is not destroyed, but it is transferred from the woolen sweater to the balloon. So if I would release the balloon, simple, it got attracted, isn't it? So now this also states a very important electric force topic, that is attraction and repulsion. So when you bring the negative balloon near the positive sweater, it flies towards the sweater, which says that the positive is getting attracted by the negative. So opposite charges attract each other. And if you use a 2 balloons mode, I'll show it to you. Okay. If I would use a 2 balloons mode in the simulation and charge them both, what happens when I charge them both? They'll push away from each other. They are not together. They'll push away from each other. So what does this show to us? This shows that the like charges repel. Even in the wall, you can see when I would pull this balloon here, when the balloon is coming here, what is happening? The negative charges are moving, isn't it? So this also shows that the negative charge, the similar like charges repel each other. Okay, so this is the most magical part of the simulation. If you bring the negatively charged balloon towards the neutral wall, what happens? The wall's electrons move away, so they repel each other, and this leaves the surface of the wall slightly positive. Why slightly positive? Because you can see here the negative electrons have moved away, and this process we call it as induced process or induction. The surface of the wall is now positive and the balloon is negative. They attract. So this is why balloons stick to a wall even though the wall itself never gained or lost any total charge. If you can see here, the wall has not lost any total charge. Only thing, the electrons had slightly moved or shifted. And this process we call that induction. Okay, so this was about the static electricity, and we can also explain students various topics like friction. When you rub the balloon on a sweater, balloon becomes negative, sweater becomes positive. This is friction. And while you release it, the negative balloons get attracted to the positive sweater. We call that as attraction. And finally, when the wall surface is positive, and because of the balloon, when the electrons move back, that is called as induction. So in one simulation, we can explain the topics of friction, attraction, induction. There is another simulation with a similar effect. So when you touch the metal knob, you get that, sharp electric shock. Would you like to know about it? Yes? No? Can we have some responses?
Ashwita ma'am, we'll pass it on to the next tutor. We are running late. Thank you,
Thank you
Ashwita
for the
ma'am. Thank you.
opportunity.
Thank you so much. Yeah, the next tutor can start. Vaidinath sir, are you ready? Vaidinath sir? We can have Vijina ma'am. Vijina ma'am? All right. Vaidinath sir, are you there? All right. Anuradha ma'am, are you there?
Ma'am, Vijina ma'am is asking to allow her.
Ganesh sir, please allow her to unmute. Ganesh sir, please allow Vijina ma'am to unmute. Ganesh sir?
Ma'am, you can unmute.
Vijina, you can
Okay,
unmute
yeah,
and speak.
yeah. Thank
Yeah.
you, ma'am.
Continue, Vijina.
Yeah, thank you, ma'am. Namaste all. Sabhi ko namaste. Today, we are going to discuss about acid-base neutralization using phenolphthalein indicator. So our objective is to help students understand the neutralization reaction between an acid and a base using an indicator and to observe color changes during the reaction in a simulation or in a virtual lab. So teachers, please be noted, the students must observe the materials required for this particular simulation or experiment. Here we have two test tubes, test tube A and test tube B, a measuring cylinder, dilute hydrochloric acid, sodium hydroxide solution, phenolphthalein as indicator, and droppers. Now, we have to ask the students to observe each step carefully and note the color changes, and let them observe how an acid reacts with a base and how an indicator help us to identify the nature of a solution, whether it is an acid or a base. So our first step is adding acid. So let us click on the hydrochloric acid bottle and give the warning that we must be very careful while handling acids in the laboratories. Now, this is a virtual lab. We have no such issues. So let us take the hydrochloric acid. Let us take about 5 ml of hydrochloric acid into the measuring cylinder. Okay, then we are going to transfer this into test tube A. Now, what is our next step? We are going to take the phenolphthalein indicator. Yes. Now, let us add 1 or 2 drops of phenolphthalein indicator to the hydrochloric acid and let the students observe the solution carefully and note whether is there any change in the color or not. Okay. Now, what do you observe? Is there any change in the color? No color change. Thank you, ma'am. Thank you, sir, Ramu, sir. So you can observe that there is no change in the color. See, the color of the hydrochloric acid solution does not change on addition of phenolphthalein indicator. That means phenolphthalein remains colorless in acidic solutions, right? Okay. Now, what is the next step? Next, we are going to add sodium hydroxide solution. Let us take the sodium hydroxide solution and then pour it into the uh, measuring cylinder. Let us take about 10 ml of sodium hydroxide. Now, then adding into the test tube B. By using this dropper, take this dropper and let us take about 5 ml of sodium hydroxide, and then we are going to add into the test tube A where we have hydrochloric acid and phenolphthalein. Now, ask the students to note down the color, if the color changes or not after adding this sodium hydroxide solution into the mixture of hydrochloric acid and phenolphthalein. Let us add it drop by drop. Now, here the students can note down the solution, it turns pink. The teacher can explain that the appearance of a pink color indicates that the solution has become basic due to excess sodium hydroxide, isn't it? Yes. Okay. Now it changes into pink color, right? Now, again, what is the next step? We are showing them the neutralization reaction, right? So again, we are going to add dilute hydrochloric acid into the pink color solution. Let us take some hydrochloric acid, and then what we are going next, what we are going to do it next? Yes, we are going to add this hydrochloric solution to the pink solution. Now, what you observe now? Gradually, the pink color fades away. This shows that the excess base has been neutralized by the acid. And this process is called the neutralization reaction, where an acid and a base react to form salt and water. Here, we teachers can emphasize the key points to the students that phenolphthalein is colorless in acidic and neutral solution, number 1. Number 2, phenolphthalein turns pink in basic solution, and neutralization occurs when acid and base cancel each other's effect. Now, a question from my side. As teachers, what examples can we give our students as real-life application based on neutralization? Let me know your answers. Yes. Yes, please, from your side. What real-life application can we give to our students, or examples can we give to our students about neutralization reaction? Okay, like we use antacids for acidity in our stomach, soap and vinegar. Thank you, sir. Yes, vinegar for wasp stings, right? Wasp sting is always alkaline. If we apply vinegar or lemon juice, it will become neutral. The pain will go away. Yes, treating acidic soil in farming. Acidic soil plus lime, it neutralizes the soil and the plants grow better. Soap and turmeric powder. Srisha ma'am, thank you. So that is all about neutralization reaction. I hope the simulation was helpful to you. Thank you so much. Next, I welcome Anuradha ma'am. I hand over the session to Anuradha ma'am. Thank you, ma'am. Thank you, Soni ma'am.
Yeah, thank you. Thank you so much, Virginia ma'am. That Vaidyanath sir, you will take up the session right now, and then Anuradha ma'am will take it up.
Yeah,
Yes.
I can take. No
Yes,
problem.
yes.
Yeah.
Take it up, ma'am.
Yeah, thank you.
Take it up, sir.
Yeah. Good morning to all. I would like to take the session of sublimation, the process of sublimation. As you all know, sublimation is a process in which when you heat a solid, that solid will get directly converted into a gas. So yeah, it directly forms the gas, it is directly goes to the gaseous form. In our day-to-day life, the example for sublimation is you all very know that naphthalene balls, and naphthalene balls which we have put in our house, it will get changed into a small if you put it as a big one, it will get changed into a small piece during the due course of time. This is the example for sublimation, and I would like to share the simulation from OLabs. Just hold on. My screen is visible?
Yes, sir. Yes, sir.
Yeah, this is the process of sublimation. In our day-to-day life, we are using all these things, iodine, as well as all our room fresheners. Room fresheners are example for sublimation process. And here we are using ammonium chloride. Here, the first step is just open the bottle and take a little bit of ammonium chloride with a spatula into that china dish. Just put it. And now it asks a question. What happens if naphthalene is used instead of ammonium chloride? Will it undergo the sublimation process? You tell yes. Okay. Now what we are going to do is we are taking the funnel. Just you put the funnel and take the cotton and just close it. Now it also asks the question. In the procedure of sublimation, the inverted funnel is plugged with the cotton because ammonium chloride is an evaporating substance which directly evaporates on heating without converting into the liquid phase. This is the answer. In that itself, they are asking you a question. So now what we are doing is we are placing this into the stand. And what now we are doing is we are just dipping the cotton in a bit of water and placing the cotton near the funnel. And once when you heat it, that ammonium chloride, now we just click on to the, just you click on, sorry. And now you take the, just. Place it near here. What happens when ammonium chloride is heated? Forms ammonia and HCl. Yeah, this is a unique process. Here we all think it's a physical change, but it is both. It's a chemical change as well as a physical change. Why it is? I'll tell in the last. Now what we are going to do is we have to burn it. Just switch on the burner so that it will heat it. And now you can see a fog-like substance. And now, which of the following substance will undergo sublimation? The answer is dry ice. Answer is dry ice. Now you can see the entire portion is like a fog-like substance is here. Here, this ammonium chloride, without attaining the liquid phase, it get directly converted into ammonium chloride as a gaseous one. So this process, it is both a physical change as well as a chemical change. Finally, the substance of ammonium chloride is reformed. So ammonium chloride, first it get decomposed into ammonia and hydrochloric acid. So that is a chemical change. When the decomposed hydrochloric acid and ammonia joins together and again forms the ammonium chloride. So this is the process of sublimation. Without any ingredients, we have demonstrated the students the process of sublimation. So thank you very much. That's it from my end.
Thank you so much, Vaidyanath sir. Over to Anuradha ma'am.
Yes,
Anuradha ma'am.
Thank you.
Thank you.
Good morning, everyone. I hope. Okay, 1 second.
Meanwhile, we have sent you the feedback form. We have got only 5 responses. Please be generous enough. Please fill in the 5 feedback forms. It's very, very essential for us. Thank you so much. So,
shall I start? Okay. Today we are going to learn a mathematical important topic called laws of exponents. So today I will explain about the simulation laws of exponents. Okay. So before going to start, let me ask one questions. One example, simple questions. Have you seen expressions like 2 cube, 2 raised to 4? Okay. So these are called powers. Okay. So powers means exponents. Okay. So exponents we are calling it as a exponents. Okay, when we use these laws of exponents, when we use a large number of calculations or bigger integers, when we use laws of exponents to accurate answer and quickly. Okay, so let us start our laws of exponents. First law is, so let's share my screen. Okay. Okay, I hope all of you see my screen. It's okay. Okay. So this is the product rule, laws of exponents. So that is a raised to m into a raised to n is equal to a raised to m plus n. Here we can use the one rule to understand the two children in easy way. That is rule number same base and add the exponents. Okay, so same base means a. Okay, a raised to m into a raised to n. Here a Naveen, sorry, add the exponents. Okay, so m plus n, a raised to m into a raised to n is equal to a raised to m plus n. Here we can give the example for students. Okay, so 3 raised to 1 into 3 raised to 3. Here, what is the answer? 3 raised to 4. We can get the 3 raised to 4. So once I check the answer. Okay. Here you can observe the answer. 3 raised to 1 plus 3 is equal to 3 raised to 4. So 3 raised to 4 means 3 is multiplied by 4 times. Okay. So 3 into 3 into 3 into 3. So our answer, final answer is 81. Okay. So 3 raised to 1 into 3 raised to 3 is 81. Okay. Okay. Here we can show the two students another simulation like this. Okay, so this is also exponents product rule. Okay, so here 2xy square into 3x cube y raised to 4. Here we can hear the expanded form. Okay, we can write here this. Okay, factorization method. So 2 into 3, x is 4 times. Okay, x cube and x is 4 times. Y is 6 times. Okay, y raised to 4, y square. This is the general solution in exponents rule. Okay, so when we can use the product rule, we can get in easy way. Okay, you all observe this easy way. So 2 into 3, x raised to 1 plus 3. Okay, here is the exponent is 1 and here is the exponent 3. So when we add these two exponents and get x raised to 4 and y 2 plus 4. So y raised to 6. Okay, so where we can coloring this also. Okay, you all observe this. Okay, and here we can change the numbers also. Okay, so 2 to minus 6 or 3 4, right, 10 up to 10. Okay, so here we can change the exponents also. Okay, you can observe, I hope. Okay, so y square to y cube y raised to 4. Correct. According to this, we can get the solution with the help of laws of exponents as a raised to m into a raised to n is equal to a raised to m plus n. This is one product rule. So laws of exponents, almost 7 exponents rules, but I only explaining one exponents rule, that is a raised to m into a raised to n is equal to a raised to m plus n. So this is my session. So over to Sony ma'am.
Thank you, Anuradha ma'am. That was wonderful. Yes. So we are back here with a small spelling rule. We will be learning a spelling rule. So meanwhile, I request you all to give your feedback. Yes, I've sent you the feedback form again. Yes. Susan, you had requested for the feedback form. I have sent you all. Please, your feedback means a lot. So do give your feedback to us. And meanwhile, I'll share my screen for the spelling rule. So, do you all know, children, that English words do not end in J? Yes, you heard it right. When I say English words do not end in the J. J, literally J, it does not end. But J sound, it does end. You would have already heard like fridge. J, J sound is there. But do you write fridge like this? I will just annotate and show you. Do you write fridge like this? F, R, A, J. Do we write it like this? No, we do not write it like this. We write it like F, R, A, D, G, E. Why? We hear the sound J, but we write DG. And if it is cage, do we write it as K, A, J? Do we write it this way? No. We write it as CAGE. Why DG? Over the here we write DG. Okay. We write DG. And here we write GE. Okay. Why? Do you want to know, children? Yes, how many of you know it? And do you want to know it? If yes, please type in the chat box. Yes. So today we are going to know why do we write DGE and GEE? Okay. What is the spelling rule behind it? Okay. Yes. I get it in the chat box. Yes, Samina says yes. And one more person has said yes. Yes. All right. Yeah. So we will definitely learn why do we have to write DG and GE. Let's start. Okay. For which you will have to know that in English, vowels have long vowel sound and short vowel sound. Okay. I'll make it very quick and simple for y'all so that we can literally start now. So English have short vowels and long vowels. What do I mean by long vowels? Simple. The vowels will tell its name. A, E, I, O, U. And Y is also considered as a vowel. Sometimes Y makes E sound. Sometimes Y makes I sound. We will not learn in depth. I'll just give you a gist of it, right? Yeah. So over here, A, E, I, O, U. When you hear the sound A, E, I, O, U, then it's a long vowel. And then you have to write what you have to write. You have to like fridge, fridge. F, R, E, E. You heard the sound, not the thing. Cage, A. You heard the A sound. This one. You heard this cage. Then you have to write G, E. What will you write? When you hear the long sound A, E, I, O, U before the J sound, you will not write J because English words do not end in J, but you will write GE. Okay, is it clear? When you hear the long sound, you have to write GE. Okay, we are clear with this. Now let's see what you have to do with this. Now let's open this box. Short vowel sounds makes the letter, it makes the sounds, letter sounds like a, e, o, e. What did I say? It will not say a. This will not say a. This will say as a. This will not say I. It will say as e. This will not say as you. It will say as a. This will not say as e. It will say as eh. This will not say as o. It will say as o. So these short sound means it will tell the sounds a, e, o, e. And long sounds means it will tell its name. Okay? A, E, I, O, U. So for this you will write GE and for this you will write DG. Like I told you in fridge, bridge. Can you see in fridge? You saw that fridge, this sound came. This E sound came. Now is it clear? You all know? Can we go for the quiz? Okay. Do I have to repeat it? Yes, what did I hear in the chat box? Let me see. Yes, feedback form completed, says Monica. Thank you, Monica. Thank you, generous of you to give me the feedback. Yes, everyone has completed. All right, okay. So do you want to repeat or shall we go to the activity? So what did I say? When it's long vowel sound, you have to say like A, E, I, O, U. You have to add GE when you hear the J sound. When it is short vowel sound like E, O, you have to write DGE when you hear the J sound. So I have repeated anyway. Now let's go to the quiz. Now all of you tell me the answers, whether we have to do long vowel or short vowel. Yes. Thank you, Maitri and Rupavati ma'am for completing the feedback. Yes. So we are almost to end the session. We'll do a small 2-3 questions in this and then we will proceed. We'll conclude. By meanwhile, you all give the feedback. Now this one is, what is this? Badge. It's badge. Which will you write? A, B, or C? Which one is that? Badge. Come on. Badge. Uma Kalyani says G. Padma says G. Baidyanath says B option. Monica says BADGE. Okay. Yes, you are absolutely right. We will write over here DGE. Why will we write GDG? Why will we write? Yes. Is my screen visible? Karthik sir?
Yes, ma'am. It is visible.
It's not paused, right? My cursor is moving, right?
Yes, yes.
All right. So yeah. So why will we write? Because see, we will represent like this. When we have short vowel sound, we will represent like this. When we have long vowel sound, we will represent it like this, a straight line. So now over here, this A is like this, short vowel sound, right? It's short vowel. So we will definitely use this only. Okay. So yeah, we will go for this. So we will go for which one? BADG, because it is badge. It's not age. We don't say it as beige. We say it as badge. Correct. And English words do not end in J, so C option is not needed at all. Now this one is very huge. Huge. What did you get? U, not a sound. U is not making it sound. It's making its what? Huge. U sound. It's telling its name. So G, correct. A option is correct. Very good. Active participation. Thank you so much. Yes, very good. And Padma, Koteshwar Ravji, thank you. Thank you all. Now this one is a stage. Can you tell me which one? Stage. Yes, A, stage. It is saying A, not stage. It's not stage, it's stage. So we will say GE. Okay, so we are, right on time. We have finished the thing. We'll do a couple of things. Bridge. Meanwhile, you all give your feedback. Eh. So it is sound. Sound, not It's not bridge. It's bridge. Okay, so that's why we say English words do not end in J, and we have DG and G instead of J. And this is how you teach them the spelling rule, and you know the spelling rule now. Yes, it's B option is right. We'll see 5. Last one we will see and we'll wind up. Age. So it's telling its name, not the sound. Age, no, page. Age. So this is right. Yes. So we are done. Yeah. So when you do it wrong, say I'm doing this one as judge. I have to mark DGE, but I am marking this. So it will show me wrong and what is right. And if you don't want to play it as a MCQ, you want to play it any other thing also, you can conduct the test that way also. For example, I'm showing you this. See this one? You rotate the wheel and ask them to select. Now, come on, Rahul, come on. This is your turn. Which is your question? Now, this one. This is your question. Come on. Tell me which will come for this. Cringe. This is how you can ask them to come and interact. So every time the child comes, can spin the wheel and get the question. Okay. So I've got the answers. Yes, it is cringe. See, consonant. When consonant comes also, you have to write GE. Okay, one more thing what you have to note. When the consonant comes, you have to write GE. Right. Thank you so much. All of you have participated very actively. It means a lot to us. Yes. Okay. So we will wind up the session. All of you have given the feedback. Yes. Anything else which you would like to know, you can unmute and ask us. Yes. Anything else, you can please unmute and also give your feedback, over here also. Anyone would like to unmute and tell us something about it? Yes. Thank you, ma'am. Yes, Samina says thank you. Thank you so much. Everyone says thank you. Yes, Hemalata says thank you. Maitri, Susan, Mamtha, everyone. Thank you, Lord. Thanks a lot, all of you, Rupavati. Everyone, thanks a lot. You've been very patient and been till the end of the session and been hearing us. You'll have been very amazing students today. Yes, amazing. A big applause for all of you for being amazing students and amazingly you have participated today. How did you feel being a student today? You've all been amazing teachers. Today you've been amazing students. So how did you feel? Can you all let me know?
Very, very, very nice.
That's nice. Thank you.
Yeah.
Thank you. Thank you. Okay, so we'll wind up. Jai Vidya Shakti, Jai Bharat, Jai Hind. Dhanyavad. Thank you. Students can, 1 minute, I'll just read the comments. Thanks, ma'am. It was awesome. And yes, students can easily learn the pronunciation of spellings, ma'am. Thank you so much, Monica says. Thank you so much, Monica, for your feedback. This was awesome, so says Susan. Thank you, Susan. Thank you. All right, so we'll wind up. Thank you, Ganesh sir. We are done.